let's talk about what arc length means, because a lot of people get arc length and the measure of an arc mixed up. So, when you go to the doctor, I just brought my daughter the other day, they usually take some measurements before you go into the room, right? They take your height, they take your weight, sometimes your blood pressure, sometimes your, temperature, all sorts of measurements. So, in the same way, I can look at this arc, and I can take different measurements. That's a weird thing happening. I can take different measurements of this arc. I can take its degree measure, or I could find its length, how long it is. Let's talk about both of those aspects of an arc. I could find its degree measure. Now, when we do degrees, what is that always out of? How many degrees if we go full circle? 360. Okay, so I know that the measure of my arc, I'm going to do M for measure, the degree measure of my arc, is always going to be a portion of 360. Now let's talk about length. When you hear length, I want you to think distance. So if an ant were to crawl, starting at A, and crawl along the curve to B, how far would it have traveled? That is what arc length is. Distance from A to B along the curve. Now, what is arc length going to be out of? Yes, it's going to be out of total distance around the circle. So the distance, the total distance around the circle is called C. It's called circumference. And we know the formula for circumference. It's 2 pi r. But anyways, so if we're missing any of these things, if we're missing the arc length, if we're missing the angle measure, if we're missing the distance around the circle, then we can use this proportion to find what we're missing. So write this handy-dandy proportion in your notes. I like to think of it as part over total equals part over total. The arc length over the circumference equals the degree measure over 360. The arc length over the circumference equals the degree measure over 360. I'll add a little degree symbol. Okay, we're going to do this first example together, and then I'll let you try and play with the proportion a little bit. Okay, so every time I want you to start with an empty proportion. I call it a template. Start with an empty proportion. Okay, now let's talk about the parts. I'll write the proportion on the board, but you have it in your notes. L stands for the arc length. I noticed in this problem, that's what I'm looking for. So that is my variable. That is my missing piece of my proportion in this problem. Next, in the next part, I need the circumference of my circle. Now, circumference is on your formula chart. So even though this proportion is not on your formula chart, circumference is, so you are not required to memorize the formula for circumference. So circumference is 2 times pi times the radius. The radius is 12. Do not press the pi button. Do not put 3.14. Do not put 3.1459265. Instead, we're going to keep everything in terms of pi. So we're doing 2 times 12, and then we'll multiply by pi at the end. When I say multiply by pi, we're going to keep the pi symbol there, and we are not going to actually press pi in our calculator. This will keep our circumference exact instead of having to round. So our circumference is always going to be in terms of pi. Then M stands for the angle measure, which is also the arc measure, because essential angle equals its arc. And this is a constant 360. When you are missing a variable in a proportion, how do you find that missing variable? Very good. So we are going to cross multiply, call it butterfly. So in our calculator, we're going to do 24 times 30. You can press the enter button. and then we're going to divide by 360. Notice how I left out pi. You know how you usually, I know you're going to play devil's advocate. You usually eat dessert at the end of a meal. Yes, I know you're probably going to say you don't because you're just being silly. Anyways, usually you save pi for the end of your meal. We are saving pi for the end of our problem. So I want you to do 24 times 30 divided by 360. And then don't forget to multiply that by pi at the end. What did you get when you cross-multiplied? 2. So how long is AB? It is 2 pi meters. Because it is a length, and we actually do have units there. Technically, this was meters as well, and I neglected to write that. But anyways. So the length of AB is 2 pi meters. We're going to keep it exact, so we're going to keep it in terms of pi. So we start with our proportion. You will memorize that proportion over time. I won't make you truly memorize it till after spring break. So I'll make sure that you get that proportion on your quiz tomorrow. So we've got L over C equals M over 360. We're given L this time. It's a little bit different. L over, okay, circumference, 2 pi r. Circumference, 2 pi r. 12 pi. L over C equals, M is our variable. We have 360. What is going to happen to the pi's? They will cancel. So, yeah, you can reduce 3 12s if you want to do 1/4. 1/4 of 360 is 90. But anyways, you don't have to ever reduce it. In fact, I encourage you not to, because I just encourage you to let your calculator do the cross multiplying so that you don't make a silly mistake when you reduce. 3 times 360 divided by 12. What's so important is that you're using common sense. Are you listening? Using common sense. Always ask yourself, what was I looking for? I was looking for an angle. Because do you know what I see all the time? I see this. I see this. I see all sorts of weird things. So what happened when we did this was the units canceled. The pi's canceled. The only thing that didn't cancel was the degree symbol. So that automatically makes our answer in the form of degrees. So our answer is 90 degrees. It is not a length, and it is not in terms of pi. Okay, let's try one more. L over C, I think that's what I'm missing because I don't know C, equals M over 360. I'll be thorough here. We're not going to find R right away. We're going to find C first, and we're going to use our circumference to work backwards and find our radius. So in your calculator, please cross multiply. Do not press pi, ever, unless I give you permission. 2.5 times 360. And then divide it by 150. What do you get? Good. So, notice what did not cancel. You get 6. Something that didn't cancel was pi. Something that didn't cancel was centimeters. So that's the full answer for the circumference. 6 pi centimeters. Now, I want the radius. I know you can do this in your head. I just want to show you where it comes from. Circumference formula is 2 pi r. The circumference is 6 pi. So when I try to solve for r, the pi's cancel, and then I divide by 2. The radius is 3. What did cancel was pi. What didn't cancel were my units. I still have units. This length is 3 centimeters long. Is it 3 pi centimeters? No. Just 3 centimeters. I saw that. A car has a turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. How much farther does a tire travel on the outside circle than on the inside? So when you're going in circles, which doesn't happen that much, but if you have a traffic circle, you would be going in circles, I guess. There's some downtown. How much more work is this tire having to do than this one. It's having to do more work, is having to travel further. So what value are we trying to find? What quantity are we trying to find? Circumference. Very good. And you even said difference of circumferences. Yes, we're going to find the circumference of the outer tire, circumference of the inner tire, and we're going to subtract them, the difference. Very good. So the circumference of the outer tire would be 2 times pi times r. That's 16.1. That's not multiplying. What about the circumference of the inner tire? 2 times pi times, what's 16.1 minus 4.7? Thank you. So this is 11.4. And we simply subtract those. Is this a real world problem? Yes. So I'm going to allow you to press the pi button. Please don't use the approximation of 3.14. Please press the entire pi button. When you subtract those, you should get, hopefully, about 29.5 feet more than the inside one. That's a lot more feet. You better go do a circle the other way next time so that those tires will be even, right? We are into section number 2 of our notes today, and it's called area of sectors. Area of sectors. What is a sector? There you go. It's a piece of pie. A sector is a pie-shaped region of a circle. We abbreviate the variable for a sector, the area of a sector. The variable is capital A, subscript SEC. Not like the football conference, but just short for sector. So the second one, yes. The area of a sector is formed by a radius and another radius and the arc that it intercepts. The shaded region, the 2D area, is your area of a sector. So it's formed by radius, radius, and arc. Sectors can even look like this. Radius, radius, major arc, Pac-Man. So yeah, we can find the area of those sectors as well. How could we use that same formula and just adjust it to work for area instead of just working for arc length? What changed and what didn't change? So it's not going to be called L anymore. We're not going to be looking for the length. We're going to be looking for A sec. Now, L was a portion of the circumference. What would A sec be a portion of? The area of the circle. The area of the circle. So there we go. That's it. That is the formula. Write it down. Area of a sector. A sec over A equals M over 360. This side, of course, did not change a bit. We are still comparing it to the angle out of the total degrees in a circle. Formula for area of a circle, pi r squared. That is on your formula chart. You are not required to memorize that. So you have to memorize the proportion, but you don't have to memorize what A equals. Let's try one. Let's start with the easy part. What is the area of this circle? Pi r squared. Don't press pi. Good. So the area is 9 squared, 81 pi inches squared. We have not been through the area and perimeter unit, so we're not really used to writing units everywhere, but I do want you to write it. It is square inches is the units. And now we're ready to find the area of a sector. A sec over A equals M over 360. Cross multiplication. 120 times 81 divided by 360. Final answer, 21 pi inches squared. That's the full answer with units. Let's try another one where we're missing something different now. They gave us a sec. A sec over A equals M over 360. Cross multiply. 4 times 360 divided by 160. So A, be careful, I know y'all are skipping ahead. When you cross multiply, you get A equals 9 pi. Oh, we don't have units. Darn, they left off the units. That's okay. A equals 9 pi. So the area of a circle is pi r squared. Pi r squared equals 9 pi. The pi's cancel. So r squared equals 9. The opposite of squaring something is square rooting. R equals plus or minus 3. You throw out the minus because you can't have a negative radius. Final answer is 3. Find the area of the shaded region. You may assume that the shaded region's sectors are congruent. Find the area. It kind of looks like a radioactive symbol, huh? I love assuming. That's so cute. So we can go about this 2 ways. We can find the area of the unshaded regions and subtract them from the total, or we can find those missing arc measures and then find the area of the shaded regions. I say we go that route. Can anyone, because for our proportion, we are going to need M. We are going to need this. So go ahead and calculate that, knowing that there are 360 degrees in a circle. So you found what they all add up, you found the answer. Cool. So these are each 30. We can find the area of one of these and quadruple it. Let's do that. I want to go that route. That's what I'm going for. So I want to find the area of one of these, and then I want to quadruple our final answer. So, A sec over, oh goodness, A area of a circle, 18 squared. A sec over A equals M over 360. Cross multiply, 324 times 30 divided by 360. The area of one sector is 27 pi, but I wanted to find the area of the shaded region, so I would multiply that times 4. It's not a real world problem. They're not really applying it to anything, so I'm going to go with 108 pi square inches. We are on to phase 3 of our lesson now. Write down segment of a circle. This is so counterintuitive, so bear with me. You were taught that a segment is a one-dimensional distance between 2 points. But when we talk about segment of a circle, we're talking about something completely different. So the area, sorry, I'm saying it again, the area of a piece of pie minus the area of a triangle will get us the area of the segment. So the area of the sector minus the area of a triangle, the area of the segment. So let's try it. So we need to find the area of the sector. We need to find the area of the triangle. And then we will know the area of the shaded region. All right, let's do sector first. Handy dandy proportion. A sec over A equals M over 360. Or you're just probably thinking, Ms. Tanton, I can just take the area and divide by 4. Yes, yes you can. Same thing. Cross multiply. The area of the sector is 25 pi inches squared. Now let's find the area of that triangle. On your formula chart, it says the area of a triangle is 1/2 base times height, or base times height divided by 2. The base is 10. Uh-oh, what's the height? Whoa, they're both radii of a circle. So the height is 10. We're not assuming that. We know that. Good. So if I do base times height divided by 2, we get 50 inches squared. So now I subtract them. And that is my final answer. 25 pi minus 50. These are not like terms. One is in terms of pi, one is not in terms of pi, so we keep it just like that. Just like in the radical unit, we might have done 3 root 2 plus 5 root 7. That would have been our answer if we were finding the perimeter. We don't combine them. Likewise, you do not combine these. Last problem of the day. Find the area of the shaded region. That is a segment. So we're going to do the area of the sector minus the area of the triangle. A set first. Area of the sector over 36 pi equals m over 360. Wow. 36 degrees. The amount of time it took me to change my 36, you could have been solving. What did you get? 12. That's a bad answer. Thank you. 12 pi centimeters squared is the area of the sector. A little bit harder. Now we need to try to find the area of the triangle. It's not 6 times 6 divided by 2 this time, because that is not a right triangle. So this is 6 again. That's cool. What's this angle right here? The measure of a central angle is equal to its intercepted arc. Whoa. So I'm going to redraw this real quick, just to help you see it. Base times height divided by 2. Now, I'm going to draw an altitude because, honestly, right now, I don't know my base or my height, and I'm in really big trouble. So I'm going to draw my height. What happens when you draw the height in? What happens to 120? Bisect. Very good. 60. Oh, my goodness, we know you. We know 30, 60, 90 triangles. Okay, so 6 is across from 90. So 3 would be across from 30, and 3 root 3 would be across from 60. We okay? I know, this is rough. Okay, base times height divided by 2. Whew, that was a lot of work. 6 times 3 is 18. 18 divided by 2 is 9. Wow, that is the area of our triangle. Final answer, pi minus triangle. Not pi as in pi, the number, but the piece of pi. Sector minus triangle. Area of the sector minus area of the triangle. Then we can put our units. Woo-wee! I promise it does not get any harder than that. That is the hardest one I could give you.